Okay, question number 38. Right. Nucleus P has 144 neutrons and 93 protons. 93 protons and 144. Okay, let us write down this equation. This is 93 and then 144. Note the change in nomenclature here. This is 93 protons and here it should be mass number. But what is it I am writing? I am writing a neutron number here. Okay, we should be careful here. 93 protons, 144 neutrons. Right. Then nucleus P is unstable and undergoes an alpha decay. It undergoes an alpha decay. So 2He, what do we write here? 4. But I don't write 4 here, I'll write 2 here. Why? Because it's only a neutron number I'm going to write here. Here also I wrote neutron number, right? Plus, I get a Q. So I want to balance this. This becomes, if this becomes 91, 91 plus 2 becomes 93. And this becomes 142. 142 plus 2 becomes 144. Note that I am writing only a neutron number. Okay, I am emphasizing this again and again because you should not get confused. Then after this what happens? And after this nucleus Q undergoes beta negative decay. So you get a minus 1 E0, minus 1 E0 plus a new nucleus which is R, Now I need to balance it once again. So if this is 91, this should be 92 over here. 92 minus 1 becomes 91 over here. And here this is 142. Don't just write 142 here. Why? The reason is because how is this electron formed? An electron is formed here when in a beta decay, beta negative decay. How is an electron formed? Electron is formed here with the neutron getting converted to a proton, right? Neutron getting converted to a proton. See, 1 minus 1 becomes 0, 1 plus 1, 0. So this is what happens. Actually, the process which happens over is something like this over here, which means the resulting nucleus is going to have 1 neutron lesser, right? Here 142 neutrons were there. Here it is going to have 1 neutron lesser over here, 1 neutron lesser over here. See, if you want, you can now find out using your mass number also, the same equation, to find whether this equation is right or wrong. Okay, now before that, let us answer the question. So, which point on the graph represents nucleus R? So, 192, 141, 92 R 141. 92 is here, 141 is here. The answer is here. Okay. Now, I told you to verify it using your normal method. So, it becomes clearer for you. Okay. So, therefore, now I will write one thing. So, I will write P. I will write P as 93. And then this is mass number. What is mass number? 4 plus 3 is 7. 4 plus 3 is 7. 4 plus 9 is 13. And then 1 here becomes 237. 230. This is your mass number. This now becomes 2He4. 2He4 plus, now what is this Q here? Q will become, this will become 91 over here. 237 minus 4 is 233 over here. This in turn will become minus 1 E0 plus, what is this R here? This should be 92 and this should be 233. If I write like this, now you can find out neutron number. If you are not conversant with this one methodology, understanding the logical reasoning behind it, you can go by this method also, the conventional method. So now you see, so what is the number of neutron over here, the final nucleus? The number of neutrons, N will now be 233 minus 92, which should be 33 minus 2 is 1, 13 minus 9 is 13 minus 9 is 4, and this is 141. So you got 141 neutrons. This is the right answer. Okay. You can either understand this method and proceed, or you can also go by this method. Okay. Any of this method is correct.